So this brings us to significant figures. As we've seen, all measurements involve some inherent uncertainty due to the thing that you're trying to measure and your measurement apparatus. And so we have rules for how many significant figures should there be? How many digits do we write down? And if we do calculations with those digits, how many should be written down as the result of that calculation? So the rules for addition and subtraction, it turns out, are different from those of multiplication and division. So for addition and subtraction, if you're doing some calculation and you know how many significant digits you have for each of the numbers that you're adding and subtracting, what you'll do is first line up the numbers that you're adding along the decimal place. And then after you've added the number, you figure out what's the smallest place that both numbers have in common. In this case, it's the hundredths place. And so your answer should be rounded to that smallest decimal place. On the other hand, if you are multiplying or dividing two numbers, then your answer should have the same number of significant digits as the smallest number of significant digits in any of the numbers that you're multiplying or dividing. So in this second example, we can see that we have this number, the 0.012, which has 2 significant digits, and this number, which has 4 significant digits. So our answer should have 2 significant digits. Now, you may not have guessed that the 0.012 had only 2 significant digits, and the 1.630 had 4. It seems like we're treating the zeros differently in both cases. And it is true that when we are trying to figure out how many significant figures are in a number, that zeros can be a little tricky. So the rules, it turns out, are different for zeros that are to the left and right of the decimal point. The big principle to keep in mind is that if a zero is necessary to tell you how big a number is, then that zero is not significant. Its job is to tell you how big the number is and not to specify accuracy. If, on the other hand, the zero is not necessary to tell you how big the number is, its job is to specify accuracy, and it is therefore significant. So let's look at some examples of that. Here we have 120 written down, and this zero in the first 120 that's written here at the top, this zero is necessary to tell us that we have 120 and not 12. If we left it off, it would be a different sized number. So since that zero is telling you how big the number is, that's its job, and it is not significant. On the other hand, the 0 to the right of the decimal point here is not necessary to tell you how big the number is. If you left it off, you would still have 120. So its job is actually to specify accuracy. You're saying that you have 120.0 and not 120.1 or some other number. So since you are specifying accuracy, then this zero is significant as well as the 0 to the left of it. So this number would have 4 significant figures. Now, if you have 120 and you want to specify that the 0 in the ones place is significant, then the way you would do that is by putting a decimal point after the 0 so that you have 3 significant figures. Although by far the clearest way of specifying significant digits is to use scientific notation. So here we have 1.20. The 0 is significant, and it's clearly significant because it's not necessary to tell you how big the number is. It is specifying accuracy. So it's a bit easier to tell when you have scientific notation that a number is a 0 is or is not significant. So over here in the right column, we apply the same principle. So when we are looking at the number here in the middle, the 0.012, this 0 and this one as well, are not significant because this 0 is necessary to tell us how big the number is. If it were not there, we would have 0.12 and not 0.012. On the other hand, the 0, this rightmost 0, is significant. So this number would have 3 significant digits. So let's do some practicing. Here we have a multiplication of 0.023 times 1.00. Which answer would have the correct number of significant digits?